Hello, in this Excel tutorial for Chem 1B, we'll be looking at the beginning of the data analysis for experiment 7. I have a worksheet already open here. I've already saved it with an appropriate name, and I've input all the data that we collected in the laboratory. For the standardization titrations, these were the ones you did with the indicator for endpoints. These are going to allow us to calculate the concentration of each of our solutions, which we'll need for the simulated titration curves. And then for the pH meter titrations that we'll be using in those experiments. Let's begin with the standardization titrations and get the basic concentrations we're going to need later on. The first thing I note about this is that I need to add a little space at the top to put my name in. So when I print it out, that information's included. So enter something descriptive, something that allow your instructor to know whose work it is that they're looking at. I'm going to leave these headings the same, but you'll notice this mass of KHP, the potassium hydrogen phthalate, and the initial volume's a little cut off. I can click that barrier between the columns on the top bar and drag it left and right to expand the size, and that's helpful. I can also shrink these spacer columns. You can double click on that barrier and it will auto width the column, which works sometimes and not others. Let's start with the standardization of my sodium hydroxide, and I'm going to enter another row so that I can put a title for each of these in. What I'm trying to calculate here is the concentration of sodium hydroxide. This is basically the same process that you used in experiment 3, and you absolutely need to know how to do these calculations by hand, but we'll do them in Excel here. I've noticed that this cell doesn't display the proper number of significant figures. I can use the increased decimal key to add the proper number of significant figures there, and same with my volumes of the burette. And remember, you read a burette to 1/10 of the division, which is 2 decimal places. And these are the burette readings for initial and final volumes for each of 3 titrations. The thing I'm going to do first is maybe calculate the volume of base that was used, volume of the titrant. And this is a simple arithmetic calculation, equals this final volume minus the initial volume. And that gives me a positive volume. That's good. If you get a negative volume, you have them backwards. And if you click this handle in the bottom right, you can copy it across. Okay. From that volume of base, I could calculate the concentration if I can get the moles of base in that size. And that's what this mass of KHP was. Recall that the mass, or the formula weight for KHP, was 204.22 grams. I've put this up above, inserting a few rows to space it out because it's useful to put these constants separate instead of including them in each equation. So down here I'm going to calculate the moles of KHP. And to do that, I take the mass of KHP and I multiply by moles divided by, or multiply by moles divided by grams, so that's divide by the formula weight, and that's going to give me my answer. As I copy this across, I want to keep this cell reference fixed, so it's an absolute cell reference. If I hit the F4 key, it toggles those dollar signs in, and that's what determines the absolute cell reference. Now if I copy this across and look at where the equation goes, this blue cell here moved across, D7, but the one I put the dollar signs in stayed fixed, and that's what I wanted. To get from moles of KHP to moles of the base that was added with the titrant, I used the reaction stoichiometry. And if you remember, KHP and sodium hydroxide are a 1-to-1 reaction stoichiometry, so that's just equal to the moles of KHP. I'm going to widen that column a bit. And finally, I calculate the concentration of sodium hydroxide, and that concentration is going to be equal to the moles divided by the volume. Okay. Now I'm off by a factor of 1,000 because my volume of base was in milliliters and I need it in liters. So to get that volume of base on the bottom into milliliters, I need to multiply by 1,000. Okay. And that has the concentration of hydroxide at about 0.1, which was the target concentration for this lab. I'm then going to calculate an average and a standard deviation of those three values. Remember that the average function is a convenient way to do that. It calculates the arithmetic mean, equals average open parentheses, drag over the cells that you want to include in that average, and hit return. Standard deviation, if you remember, was STDEV, equals STDEV, open parentheses, the cells you want to take the standard deviation of, and enter. I'm going to adjust the significant figures on these numbers so that they display properly, but keep in mind that Excel is keeping the entire series of numbers, and that will help us avoid rounding errors. Next, I'm going to move to calculating the concentration of the acid in our Ex7A video.